Hey everyone, very good morning to all of you and welcome back to the channel where we are going to learn many important and easy tricks for the final NEET exam. So I hope your preparation sitting back at home and enjoying the lectures is going very well, and I'm expecting that you are revising the learned things on daily basis. As I always suggest, revision and doing it again and again is the key to success in the NEET exam, because syllabus is huge. So if you do the daily revision, then only you will be finding it relatively easy to complete the preparation thoroughly. Okay, so let us try to understand few more things. So generally in these type of sessions, I prefer to take different topics which make you score in the exam. But since last 3 days, if you notice, I am chasing the same topic, that is the topic of oscillations, because the NCERT cases are the two standard cases of simple pendulum and spring mass system, which we have already discussed day before yesterday and yesterday, like in the last two lectures. And today we are going to discuss few more case studies from the additional and exercise questions of the NCERT, as well as a basic review of the chapter entirely, oscillations or simple harmonic motion, which will help you out to complete the entire chapter very easily. Okay, so you can take this as a closure lecture as of now for oscillations or SHM. Obviously, this doesn't contain the 100% of the syllabus. This contains the most scoring part, or sometimes the part which is not itself appropriate, or which is not itself that much relevant for the exam, but learning those things will definitely strengthen your fundamentals to learn the rest of the physics. Okay, so it's not the game of 45 days and 45 questions in the NEET exam. No, if you strengthen your fundamentals, you can complete the syllabus in a very short span of time, but strengthening the fundamentals sometimes take a lot of time. Okay, so on an average, we will say that the 1 year journey of us together for the preparation of NEET exam, we will keep having these kind of sessions, and we will keep learning many new things. So you also make sure that you revise everything thoroughly. So the topic name is oscillations or simple harmonic motion. This is the second last chapter of the 11th class NCERT and 11th class syllabus, and we will see how we are going to prepare it. So generally, when we teach simple harmonic motion, that is personally my preference also, that I prefer to teach this topic in 3 different phases. First of all, we talk about general relations. All the numericals, all such kind of things will come here. General relations we will study as a function of time, and we also study as a function of x, where x is always the disturbance or displacement from mean position. Disturbance or displacement from mean position. Okay, mean position. Fine, mean position is the most stable position, equilibrium position, potential energy is minimum, all those things are certainly valid. Now, if I say as a function of time, you don't have to remember this, you have to practice it. So I suggest you to practice them. You have to practice these. And as a function of x, you have to memorize them. Okay, obviously I will explain it to you all. So first of all, understanding is there, but there are 2 categories of general relations. One is as a function of time, that you don't have to memorize, you have to just practice. Orally, differentiation, you will do some differentiation, sometimes the basic formula of kinetic energy half mv square, potential energy half kx square, and you can easily get that category of result. Now next thing we are talking about, so this is all about the general relations we would talk about. Next will be graphs. Again, graphs for the relations based on x, and these are relations based on t, relation based on time t. So naturally, if you don't have to remember the time relations, so you don't have to remember the graphs either. Okay, you will just practice them. But the graphs on the relations based on x, you have to definitely remember. So on the basis of x, the formula you have to remember, as well as the graphs you have to memorize, you have to remember. Okay, direct questions will be coming from the graph in the final exam. Fine. We talk about the third one here. If we are talking about the third one, here is time period of physical systems. Time period of physical systems. Now in this, we talk about number one, simple pendulum. Simple pendulum. So if you remember in the very first lecture, 2 lectures back from now, in the very first lecture of simple harmonic motion or oscillation, I told you the simple pendulum. Then yesterday we had a discussion of, yesterday and day before yesterday, we had a discussion of spring pendulum. So the simple pendulum is an example of angular SHM, and the spring pendulum is the basic example of linear SHM. The disturbance you will provide will be in the form of X, the compression or extension provided in the provided to the spring. And remember that these two are the NCERT cases. These two are the NCERT cases. NCERT cases, case studies. Okay, so these are very much important and we have already completed them separately. If we talk about the remaining things, I mean, we can combine different aspect of time period in different physical situations. For example, we can talk about the SHM plus gravitation, SHM plus gravitation cases, this will involve the oscillation of block made inside in the tunnel made along the diameter of earth or chord of earth, like that. Then it is SHM plus fluids, oscillation of a body, oscillation of a floatable body over the surface of fluid, over the surface of a liquid, oscillation of a liquid inside a U tube, V tube, U tube, like that. Those cases will come SHM plus fluids, and many more. Combination with electrostatics, combination with magnetics, these will keep coming. There will be a lot of cases. So these two are the NCERT cases which we have already covered. Once you will come to us and we will go ahead with our preparation, we will be talking about the relative also. Okay. So ultimately, I hope the basic idea for you is fine. I would suggest you to take the screenshot of this, because it's not like just mere index. In fact, it is a checklist which will be very, very helpful for you to finalize your NEET preparation at the end. So treat it like a checklist. Take a screenshot quickly. Right. I hope you have already taken a screenshot. So notes will be otherwise also provided to the Telegram group. And apart from that, if you want me to teach any other physics topic, you can let me know in the comment section. Or if you want to learn from already a taught topic to you, you can just write on the YouTube search bar this, the name of the topic. For example, electrostatics and capacitance, electrostatic potential and capacitance by Abhilash Jha Sir Physics. Okay. So you will get a lot of videos to learn from this stuff. And don't forget to like, share and subscribe this video. Share it to many of your friends so that everyone can have a learning experience. All right. So let me take you to the general relations part. General relations. General equation of simple harmonic motion. General equation of SHM. General equation of SHM is, that is, x equals to a sine omega t plus phi, right? X equals to a sine omega t plus phi. A sine omega t plus phi. Here x is always going to denote disturbance from mean position. Where the particle is starting, that doesn't matter to you here. Even if the particle is starting from the mean position, then also x will denote disturbance from the mean position. Even if the particle is starting at from some other point, then also x is going to denote disturbance from the mean position only. So it will always denote disturbance from mean position. and where the particle actually starts from, that will be decided and governed by the value of phi. So here you will say now that A is going to be the amplitude. Amplitude, maximum disturbance from the mean position, that is x max. X max, maximum disturbance from the mean position is amplitude. Here we will talk about the omega. Omega is basically angular frequency. Angular frequency. Angular frequency. What is the relation of omega? Formula for omega is 2 pi f, and that is 2 pi by capital T, where this T is time period. This T is time period. All right. Next is small t. Small t is not the time period. Yes, it is the time, but this T is basically the time instant. Time instant. Okay, the instantaneous value of x. If you want to find out that at any particular instant where the particle is, what is the disturbance of particle from the mean position at a particular instant. So that will be governed by the value of x. Only if you put the value of t, time instant, you have to keep it here. And if we talk about the value of phi, that denotes initial phase. Initial phase. It's a very important quantity, initial phase, that tells you where the particles start from and in which sense. It tells you about the initial situation. As the name itself suggests, that tells you about the initial situation. Initial situation means where the particle is starting from and in which direction. Where the particle is starting from and in which direction. I'll give you some idea. On the basis of a line diagram. But before that, another thing what you need to understand is total phase. This omega t plus phi, value is also called commonly as total phase. Means total phase will be dependent on initial phase, where the particle starts and in which direction, the time that has been spent, the time instant, as well as the omega, angular frequency, 2 pi f or 2 pi by t. I think that's clear to us. Easy, right? Now we are going to talk about the other thing, that is, I was suggesting you the line diagram. In order to understand every aspect of simple harmonic motion, sometimes in the case studies as well as in problems, we will consider a line diagram. We will consider a line over which we will try to represent the motion, of particle executing simple harmonic 1. Okay. So I will say this is x equals to 0, mean position. This is x equals to 0, mean position. This is extreme position 1, extreme position on the positive side. So this will denote x is equal to plus a, forward motion positive, and this we can commonly call it as EP2, extreme position 2, and here x is equal to minus a. For velocity, you can say that here at EP1, velocity will be minimum, and that minimum velocity will be 0. Extreme position pe velocity should be 0. That's why you are calling it as extreme, that the particle goes and goes and goes and ultimately it stops. So that's why it is called as extreme. And for mean position, you will say particle's velocity will be maximum, and that will be plus minus a omega. Why plus minus, sir? Naturally, if it is moving in the positive direction, you can take it as positive. Forward motion, positive motion. Conventionally, backward motion, you can take it as negative motion. For our analysis too, we'll be going ahead with that. But right now, the situation is that we wanted to talk about the value of initial phase. Suppose the particle starts from mean position. And it wants to move ahead. If it wants to move ahead, you will say the phi value will be 0. In fact, I would like to represent it here without missing out anything. Okay, I'm representing it here without missing out anything. So I will say that V minimum, V maximum, V minimum, we will talk about it. Okay, separately also. And let us talk about the phi ones. So first of all, if the particle starts from mean position and it is moving ahead, and if it is moving in the forward direction, so you have to take the phi as 0. I will explain it to you that why I am telling you all this, but as of now you have to remember few things, then you will understand it better. Similarly, if the particle is starting from mean position, but it is moving back, if the particle is starting from mean position, but it is moving back, then what you have to do? Then you have to take the value of phi as pi, 180 degrees or pi. Okay. If the particle starts from extreme position, then it doesn't have two choices to move forward or backward. No. If the particle starts its motion from extreme position, then it has only one choice, to come back. Similarly, if the particle is starting its motion from EP2, again it has only one choice, to move ahead. Okay. So here only one value of phi is suitable, that is pi by 2 or 90 degrees. And here only one value of phi is possible, that is 3 pi by 2 or 270 degrees. And if you understand that carefully, you will realize that if the particle is moving from mean position to extreme position like this, like in this direction, then its phi value belongs to the first quadrant. First quadrant means that is belonging from 0 to 90 degree, both excluded. Because if it is from 0, then it is exactly starting from 0, then the value of phi in this equation, you are supposed to take it as 0. If it is starting from EP1, then pi by 2. But if it is starting from somewhere in between, then the particle had a choice either to move towards extreme or to move towards mean. So if the particle is starting and moving towards extreme, I'll tell you separately how you are saying like that, sir, how to calculate the exact value. Don't worry, we'll talk about everything. But before that, we need to understand what is the range. So if the particle starts from somewhere in between and moves in the forward direction towards the nearest extreme, you will say the value of phi should belong to the first quadrant, 0 to pi by 2. If it is starting somewhere in between but moving towards the mean, then it will be pi by 2 to pi, both excluded. Exactly here it is pi by 2, exactly here it is pi. Similarly, if you are going like this, then the phi value belongs to third quadrant. It is pi by 2 to pi to 3 pi by 2. Pi to 3 pi by 2. Is that fine? I think that's fine with us. And if that starts from something in between but goes towards the mean, then phi will belong to fourth quadrant. That is 3 pi by 2 to 2 pi or 0. 3 pi by 2 to 2 pi or 0, fourth quadrant. So basically you can say first quadrant, second quadrant, third quadrant, fourth quadrant, first, second, third, fourth, like this. So if you remember this, it will be easy for you to understand the things in a better way very soon. Okay? So what I'm trying to tell you is you can represent every physical quantity related to the simple harmonic motion with the line diagram. Okay, so we will talk about the line diagram separately, and this is the introduction of the general equation of simple harmonic motion. Along with its value, the appropriate value of phi you have to choose according to the motion of the particle. Okay, you do one thing, you quickly take the screenshot of this, then we will move ahead. And first of all, we will try to talk about some more general relations, some more quantities depending upon the value of x and their graphs. At the end, we will talk about the calculation of the value of phi 2. Okay, how to calculate? Sir, you told, but you didn't explain. Yes, I told. I'm going to explain it at the right time. Okay, take the screenshot quickly. Okay, fine. I hope this thing is clear to you. All right. Chaliye. Taking you ahead. Yeah, good morning. Sweet memories. Good morning, yeah. Good morning, all of you. So yeah, once you leave the campus, this is the major way. Online is the only way. Most of the times we are able to connect, and I'm glad that the students are still looking for videos and all. I definitely consider it your affection towards the teachers, your memories, and we also miss the same year. And to all the new students who are actually watching this video here in the campus, basically what happens now that students are staying here in the residential campuses. We being from teaching team, we also prefer to stay with the students. I mean, the teaching hours are 5-6 hours like that, then the study hours for 2 hours. But whenever the students are working hard, definitely we also feel that we have to put some extra time and we stay there. Every teacher in the campus will stretch their working hours to be with the students, to help in each and every individual step, which is, enhancing your score and taking you towards your actual goal. So in the process of that's what I was talking about, the sweet memories, that yes, working for the subject for 13 hours, 14 hours a day constantly for 6 months or 1 year, it's a tough task. But definitely, yeah, this is the phase which always makes you grow in life, and we are always glad and happy we are always happy, as well as we feel sometimes a bit proud that to be a part of your journey to success. So thank you so much. Yeah, let me come back to the point. So general equation of simple harmonic motion, the line diagram representing that. Now I will talk about the category general equations in terms of x. In terms of x, where x denotes the disturbance from mean position, the particle may start from mean, the particle may start from extreme, the particle may start from any of the infinite positions possible. But these are the fixed relations. So you have to memorize them. No need to derive anything. You need to memorize them, and I will explain them. So how they are coming, we don't care a lot. But since what is the relation and what are the numericals based on relation, that we can easily practice, and by that way we can remember that. So first of all, I would like to talk about the velocity, that is omega under root mein a square minus x square. Then second one is the acceleration. That acceleration will be equal to minus of omega square x. Okay. Then it is the force. F is equal to ma is equal to minus of m omega square x, or this minus m omega square can be written as k, so that is minus kx. So these are basically the conditions for simple harmonic motion, and this is a very important formula of velocity related to the simple harmonic motion. Similarly, if I just take the next three relations, it will give you some more clarity. So I have taken these three relations. We'll talk about them one by one, their values, their representation on the line diagram, their graphs, everything. Number 4, we would like to talk about kinetic energy. Since kinetic energy is half mv square, and if you see the v value was omega under root mein a square minus x square, if you are going to do it square, then you will get half m omega square a square minus x square. Half m omega square a square minus x square. Similarly, fourth one, you will write potential energy U as half k x square. But if you see that carefully, the value of k is nothing but m omega square. Where you will say omega, we have used it earlier also, omega is under root of k by m, or k is equal to m omega square. Okay. So same thing I am using it here, that half will remain half only. K value will be m omega square, and x square will be as it is. This will be the fifth relation. Okay. Now if we talk about the total energy, so that will be kinetic energy plus potential energy. So kinetic energy plus potential energy, consider that you are adding these two. If you are going to add these two, then half m omega square a square minus x square plus x square. If you add these two and you take half m omega square common, that's a square minus x square plus x square. Minus x square and plus x square will be cancelled, and you will be having half m omega square a square. That is basically a constant. Half m omega square a square, that is basically a constant. Alright. Hope the idea is clear. So we are going to memorize these 6 relations, 6 formula you have to memorize. Number 1. Number two, you have to understand their representation or their values at different positions. So we are going to represent it over a line diagram. Number three, you have to plot their variation graph. We are going to talk about. Then also along with the line diagram and graph, we will find some similarity in representing the minimum and maximum values. Let me take you to them one by one. First of all, we take v equals to omega under root mein a square minus x square. So if I want to plot, obviously it's velocity, so it can be on the positive side as well as on the negative side. And this is x, it can go up to minus a to plus a. Whatever the graph you are trying to plot, that graph must be going from minus a to plus a. So x equals to minus a to x equals to plus a. In between this region here, the graph can be drawn. Okay. So first of all, I'll be putting for mean position. For like if x equals to 0 or for mean position x equals to 0, what we have? Mean position ke liye x equals to 0. So if you put x equals to 0 here, it is under root of a square. Under root of a square. What is the square root of 4? What is the square root of 4? Don't tell me 2. Say plus minus 2. Square root of 4 is going to be plus minus 2. So basically you will say here that under root of a square is going to be plus minus a. So velocity will be equal to plus minus a omega, because omega is also standing outside and it is going to be the maximum value that can be attained. So obviously when the particle is at mean position, it is the fastest. And if you want to talk about extreme position, for extreme position ke liye x can be plus a as well as x can be minus a. So x can be plus minus a. Okay. So now what we will have? We will have v is equal to 0. The reason is if you put plus minus a, its square is a square. It will be cancelled and hence the answer is 0. And logically also it is correct. Because if you are calling it the extreme position, that is the maximum position. So particle cannot go beyond that. It has to stop there. So v value is going to be 0 and obviously it is going to be the minimum value. So what you can do is you can just try to mark the points and then join them free-handedly. So if you put x equals to 0 means origin. You have velocity as plus minus a omega. So this will be the point called 0 comma plus a omega, and this will be the point called 0 comma minus a omega. So 0 comma plus a omega and 0 comma minus a omega. This will be the point. Okay. Then when x equals to plus minus a, the velocity will be 0. So this will be plus a comma 0 and this point is going to be minus a comma 0. Naturally you are going to get, if you join them free-handedly, you are going to get an ellipse. Isn't it? If you join them free-handedly, you are going to get this type of ellipse. Okay, so the graph what you are going to get here is naturally an ellipse, elliptical form. Hope you are getting it. So one way of drawing any graph is equation comparison. You have the physics equation, you know the general equation of ellipse, hyperbola, parabola, straight line and all. So you can draw the graph. Another way of drawing any graph is, sir, we don't want to deal with equations. We don't like to remember so many equations. Then what to do? Universal method of drawing the graph. Mark some points and join them free-handedly. Definitely you will get that. Okay. For example, if I try to represent the same, if I try to mention you the same in other way 2 of plotting the graph, that is, let's say equation comparison. So we will say equation comparison mein we will try to compare it with any standard equation. So for example, we are having v equals to omega under root a square minus x square. From here we can write it as v square by omega square is equal to a square minus x square, taking the omega here and squaring on both sides. So what we got is v square by omega square plus x square is equal to a square, or you can write it as x square by a square plus v square by omega square a square, that is equal to 1. that is equal to 1. Clearly, it can be compared by the equation x square by a square plus y square by b square is equal to 1. Hence, that is nothing but an ellipse, standard equation of ellipse. That is going to be the standard equation of ellipse. Okay. So, one way of plotting any graph is the universal way. If you don't want to learn so many equations, if you don't like to draw a lot of graphs in physics, then what you can do is just mark few points and join them free-handedly. That's what you have been doing since your childhood, isn't it? Now, another way of doing that is standard equation comparison. Since we are learning this today, we have to learn something more, है ना? Chaliye, let's talk about the next one, that is a equals to minus omega square x. Again, I will say acceleration being a vector quantity can be on the positive side as well as on the negative side. Moreover, x, the disturbance from mean position will also vary from minus a to plus a, minus a to plus a. So the region, the feasible region for the graph, the feasible region or possible region for the graph is going to be only this much. Okay. And this will be from minus a to plus a, minus a to plus a, and this is going to be the origin. Okay. Now I'll try to take the support of one thing is for sure, that the variables you are talking about are acceleration and x, and both are having power 1 1. So isn't it a linear equation in two variables? So it is going to represent a straight line. Moreover, you see it is y equals to mx where slope is negative. So y equal to mx has to be a directly proportional straight line passing from the origin, but minus of omega square means negative slope. So instead of this graph, you must be having this graph. Okay. So this is by equation comparison. We can talk about it. But before that, we have another way of doing it, that is the marking of the values. Universal way, mark some point, join them free-handedly. So what you are going to do? You will say for mean position x equals to 0. If you put x equals to 0, then acceleration will also be 0 and it is going to have its minimum value, minima. And for extreme position x equals to plus minus a. If you put x equals to plus minus a, the acceleration will be minus plus omega square a. Means when x is positive, the acceleration is negative, and when x is negative, acceleration will become positive. Moreover, it makes more sense when you talk about oscillations, that if the body is going in the forward direction, it will be pulled backward. And if the body is going in the backward direction, it will be accelerated, or force will try to bring it back to the positive sense. So acceleration or force and displacement must be always oppositely directed. Okay. So this is minus omega square, minus plus omega square a, and it is the maximum value. So the values you are going to mark is 0, 0, 0, a and x both are 0 simultaneously. When x is minus a, the acceleration is positive of omega square a, So this is the point. And when x equals to plus a, the acceleration is minus of omega square a. So this is the point, minus of omega square a. I repeat, when x is 0, acceleration is 0. When x is positive, acceleration is negative. When x is negative, acceleration is positive. If you want to draw the graph is going to be like this. Join these 3 points free-handedly. So it is going to be a straight line passing from the origin, having a negative slope. Okay. Let's talk about the other one, the third one, that is f equals to ma. So you are just multiplying the second case with a positive constant m. So it's not going to create a huge difference. It is not going to create a huge difference here. In the graph, it will be exactly symmetric. And how you can plot it? F, you are plotting it. So ma. So again, you will say that it is going to vary from minus a to plus a. If it is going to vary from minus a to plus a, this is origin. Then you will say when x is 0, you can do directly here. When x is 0, the force is also 0. So this is the point 0, 0. When x is plus a, the force is minus of m omega square a, or you can write it as minus ka. This is the point. And when x is minus a, the force is positive of m omega square a or positive of ka. So here will be some point like this. And if you want to join them free-handedly, you will do it like this. Exactly similar graph you will get here. Okay, so second case and third case are coming out to be quite similar, because how to get the force? By multiplying the acceleration with mass, which is treated as a positive constant. So the design will not change, the slope will not change, nothing will change, only the values, exact values are going to be changed. Okay, so I hope these things are clear to you. Quickly, you can take a screenshot. Take the screenshot. All right, all right. So in physics, I got 140 because of you, sir. Thank you so much. Yeah, first of all, congratulations. You got good marks, and there is a lot going on these days, especially regarding the NEET result, NEET ranking. So don't get demotivated. Every day there is something new going on. So have some patience. We will definitely get on to some conclusion. Okay, number one. Number two, yeah, we worked hard together, but the credit of doing extreme hard work and getting such a good score in physics goes to you. So congratulations all, whosoever has, whosoever have got the great scores. Again, I'm telling you, don't get worried about the ranks, that even at such a great score, why we are not getting good ranks, sir, this year, what will happen next, how we can talk about the aims, like how we can target aims, should I take a drop again or this or that. Have some patience. Okay, we'll talk about everything separately, but be patient, because again I'm telling you, there is a lot going on every day. So we cannot conclude something today directly, because tomorrow morning again another news will come. Okay, a different news of maybe the paper leak, maybe the what you call the normalization score, how many people are getting the AIR1, this, that. So there is a lot going on social media. Just take some time to decide anything. Okay, yeah, but definitely if you are preparing anyways for the good, better colleges, for what you can expect this year, definitely you should not delay joining your long-term batches. Okay, here we can definitely start the preparation. We have already started. You can also join very soon. But if you are having a very good score and still you are in dilemma that no, till last year, so at this score we got the Andhra Medical College, or maybe we got the JIPMER, or maybe we got the AIMS, but this year what will happen? Then in that case, I would suggest you to take some time, be patient, calm down. Things will align in a better way, but it might take some time. So things are going on, people are fighting for it. We are also putting many, we are also taking many steps to sort out the things. So we will get some good outcomes. Okay, don't worry about it. Sir, I have got 662 marks and now about 3 days I am depressing. That's what I am talking about. Himanshu, that you don't have to worry about it. Yeah, 662 marks, it's a very good score. Okay, but considering this year, I won't say that this year you have scored poor. It doesn't make sense. Considering this year, since the normalization and other criteria were involved, you are getting maybe not that much expected good rank, but take some time, the results may revise very soon. So we are expecting that, don't worry about it. But there is no clear-cut information regarding that till now, regarding anything. So we are also on waiting. You also wait, something good will happen. Spandana, is it good to take drops, sir? Yeah, that depends on the goal. Okay, I say taking a drop will always be a good decision if you yourself internally have a goal that I have to upgrade my rank, I have to upgrade my result, I have to join a better college. Okay, so if there is a target in your mind that you have to join, you want to join, that the fire is inside, that you want to join a better college, you want to fight for your career, then taking a long term is always suggested. It's not bad, right? But if you are thinking that no, I have nothing to do, I will just take some campus, I will start doing long term, maybe something will happen. Then this maybe is a never ending story here. And it's not only about taking an admission for a medical course or academic part, it's everywhere applicable throughout the life. If you're sure about something, then you should make decisions. If you're not sure about something, then don't make any decision. In fact, Google some more options, and you Google some good medical colleges, see what are the target colleges which you would like to get the admission in. Then accordingly, what is the rank required? Then according to that rank, how you should prepare. So you need to have a clear-cut goal. Okay. Once you have a goal, the day when you start pursuing your goal with complete clarity, believe me, half journey has already been positively completed, because you internally are quite strong and quite sure that how you want to pursue your preparation. Okay. Then in that case, you can surely go ahead with the draw. Doesn't matter here. I mean, anyways, by selecting the medical as your medical field as your career, you already have decided that you are going to invest a lot number of years in the MBBS college, then after that for the postgrad, and then certain examinations and all. So if you have already decided to invest so many years, after becoming a after becoming a successful doctor down the line, no one is going to ask you how many times it practically took you to get into any AIMS medical college. It may take 1 year, it may take 2 years, it doesn't matter here, right? But having a good college and then having a good skill set and a clear cut goal is very much necessary. Okay, that's my personal opinion. I would suggest you, if I would have been at your place, if I would have been there, then I would think about my goals first, then I will think about the college. Accordingly, I will channelize my preparation. Okay. Yeah, I don't have that clear cut idea regarding the different categories and different category ranks. And obviously, I don't have those on my tips. So I would suggest you to open the college website and go through the closing ranks of 2023, closing ranks of 2022 for UG program, undergraduate MBBS, NEET based programs. Okay, they will give you a clear cut idea. RK3925, I'm talking to you. Right. Chaliye, I think I have taken few of your queries and my suggestions would help you to calm down a bit. And I hope you have learned these things also. So just keep revising after taking the screenshots, just keep revising. And the notes will also be provided to you in the Telegram group. Apart from that also, if you want to learn from any of my lectures, as I already mentioned, you can just mention the name of the topic by Abhilash Jha Sir Physics. Like this, you can mention in the YouTube. You'll get a lot to learn. All right. So all the best. Hope to see you soon. Bye bye.
Good morning, one and all. Today is in our botany lecture. We are going to take the two topics, the fruit and the seed. I hope so you have gone through the previous lectures, the revision of that. We did up to the gynoecium part, and now we are going to take the next over the part. What is that? The fruit and the seeds, right? So let's take the first, the fruits topic. So a general concept regarding the fruit, what you need to learn is that the fruit, can I say this is the ripened ovary, right? What is the fruit? This is the ripened ovary. Means after fertilization, the ovary part, what we have discussed in the carpal, right, basal swollen part, will get into the fruit, and this is the characteristic feature of the angiosperms, right? Now this ripened ovary, this is the product of the fertilization in case of the angiosperm, double fertilization, right? That detail we will discuss later in the sexual reproduction in flowering plant. But right now, just morphological points we have to pick up for this topic, right? Now, let's talk about their types. Types of fruit based on which part is giving out the fruit, right? So, based on that, we are having two types of fruit. One is the true fruit. Next is a false fruit. Right? What is the true fruit, right? True fruit is that fruit which develops from the ovary part. If it is developing from the ovary part, that means that fruit we are taking as a true fruit. And if it is developing from the part other than the ovary, right? If it is developing other than the ovary, like in case of thalamus, if thalamus is giving rise to the fruit, that type of fruit we call it as a false fruit, right? For example, in case of mango, it will be completely, will be the true fruit. For example, in case of mango, it will be the true fruit, right? And if I take the concept of the false fruit, like from the thalamus, then example will go with the cashew, right? Even for the strawberry and even for the apple, right? This topic is very, very important, being it is linking the two chapters together. One is the sexual reproduction in flowering plant, next is a morphology, right? So be careful, this topic you will be getting there as well. So obviously the importance of this topic is more. Okay, now false fruit, suppose if I am discussing about the apple, right? The thalamus part will become swollen and the fleshy. If it is becoming edible fruit, then means it is the false fruit which is other than the ovary. But it never means the true fruit is absent in the apple. Even true fruit is there. In the central part, what you actually throw where seeds are embedded, that part is a true fruit. And fleshy, what you eat, that is the false fruit, right? So false fruit can be there in a fruit along with the true fruit. But true fruit is formed after the fertilization from the ovary part. But false fruit is formed from the part other than the ovary. The other term even we can use for the true fruit, what is that? You call it as a eucarp. Wherever you get the word eu means what? True fruit, and carp means fruit, right? The true fruit which is developing from the ovary part, that you call it as a eucarp. And false fruit, what do you call it as a pseudocarp? Pseudo means what thing? False. Carp means fruit. The fruit which is falsely developing from the part other than the ovary, right? That is a pseudocarp. So those are the types of fruit based on the part of gynoecium from where it develops. Now let's talk about the parts of a fruit. Right? Next point we have to take for the parts of the fruit. Basically, there are the two parts. What are the two basic parts of the fruit? Number one, it will be having the pericarp. Pericarp is what? See the word here, peri means around. Around the fruit, there is a fruit wall. Right? That fruit wall you call it as pericarp. Okay, so due to some technical issues, a little bit problem happened and I need to stop the lecture in between. Let's continue with the stuff. We are discussing about the parts of fruit, where we discussed about the pericarp, which you call it as a fruit wall, right? Now, next part will be the seed, right? Seed is the, like you can say this is a first stage for the next generation. Now, based on the pericarp, how many types of fruits are there? Based on the pericarp, there will be two types of fruits further. One will be the dry fruit, second will be the fleshy fruits, right? Let's talk about fleshy fruit first, then we will discuss about the dry fruit. In the fleshy fruit, the pericarp is differentiated into three layers. What is that? Epicarp, mesocarp and the endocarp, right? The differentiation is there for all the three layers in case of fleshy fruit, whereas in case of dry fruit there is no differentiation. There is no differentiation of such type. Are you getting that? Differentiation of such type is not there in case of dry fruit. Now coming to the seed part. In the seed part, we have to discuss later the two parts of that. One is the seed coat, second is an embryo, right? Now seed coat further are of two layers. One is testa and one is the tegmen. Do remember, testa is the outer layer, whereas tegma is the inner layer, right? Testa and the tegma are there. Testa is the outer one, whereas the tegma is the inner one, right? So do remember this part. Embryo consists of what thing? It consists of embryonal axis, and add on to that it is made up of cotyledons, right? Two cotyledons, in which case? Two cotyledons in the case of dicots. One cotyledon in case of monocot, right? So do remember this point, that we are going to take these classification or the categories of the parts based on, here the seed coat is covering the outer, whereas inner the embryonal axis it make it safe, which has to give rise to full plant when you sow the seed, right? Now coming to the next point, back to the fruits. Just now we have to complete the part, the fruit first of all. The outer fruit wall, we decided the two types of fruit based on this pericarp. Example for that, dry fruit, here we have to take the example like of mustard, even of the pea, right? These two examples will come. So today a little bit problems we are facing. I hope so. Voice is audible to everyone. Please check it once if I am audible. Please check the screen. Is that visible to everyone? Just have a look once. Okay, fine. Fine. So now we are going to take the example we were discussing, mustard and the pea. The scientific name, what we have to take for the pisum, right? Brassica, scientific name, what we have to take means the brassica is a scientific name for the mustard, right? And flesh fruit, for example, mango, right? Mango. What is the scientific name to the mango? Anyone, please? Scientific name to the mango. Very easy question I asked. I hope so. You are there on the screen. Mangifera indica, right? So Mangifera indica, this is a scientific name to the mango. Very easy question I asked, so that at least you can participate in the ongoing lecture, because I am feeling like that students are more after like they are talking to each other more. But please have a look on the lecture as well. As per I said that the fleshy fruit means there is a proper differentiation of epicarp, mesocarp and endocarp, right? Their example I kept for the mango, right? Seed I will take later. Parts I have already discussed with you, right? Okay, now these are the types of fruit based on the fruit wall, whether it is properly differentiated like this or not. If it is not, then that type you call it as dry fruit. If it is differentiated, then you call it as a fleshy fruit, right? Okay, now coming to the next point. Further, we have classification of fruits based on that which flower has given that. And on that grounds, let me to say you here, according to your NCERT, they had given one simple fruit. Under the simple fruit, one of the type they have given for drupe, right? And under the drupe, they have given the example of mango and the coconut, right? Mango and the coconut. Right now you said me Mangifera indica, scientific name of mango, and here is for the cocos, scientific name for the coconut, Cocos nucifera. That will be the name for the coconut, right? Now coming to the next point here, the simple fruit is what? Which is developing from the single flower, right? It is from the single flower, one flower, it is forming. But if it is like in one flower, you are having that I can say one flower with more than one carpel, then it should be syncarpous condition. Otherwise, single carpel can even give rise to this fruit, right? Single carpel even can give rise to this fruit. So we have simple fruit, aggregate fruit and composite fruit. Simple fruit, I repeat, it is from the single flower. Single flower, one carpel can give rise to one fruit. If it is more than one, then they should be fused. That type of fruit we call it as a simple fruit, right? Now this mango and coconut, that belongs to simple fruit drupe, but still there are some similarities between that, although they belong to dicot and this belongs to the monocot, right? So what are that dissimilarities or monocots and dicots that we will discuss based on the what we can say seed, right? Otherwise morphology even we have discussed few points based on dicots and monocots, but still we have to discuss about the dicot and monocot regarding the seed. But the fruit, the mango and coconut commonly is having of the drupe part, right? Now, will it is having simple aggregate or composite type of fruit? It is having only the simple type of fruit. Under the simple type, it is a drupe type because it can be berry, right? It can be like a like Papo will be there, Hesperidium will be there, different types of simple fruits are there. We are not in that much of detail. You must know the important thing for your NEET exam. What is that? Drupe fruit comes under the simple fruit, which is a type of a fleshy fruit, right? So even do remember the feature of the drupe. What is that? It is the fleshy fruit, right? And this fleshy fruit is formed from the superior ovary, right? And what differentiation it is having with the pericarp? It is differentiated into epicarp, mesocarp and endocarp, right? They are differentiated into that. Clear? Both in the mango and the coconut. But do remember, in case of mango, the mesocarp is going to be edible, right? Whereas in case of coconut, what thing is edible over there? Here, the endosperm is edible. And do remember, coconut is having the double endosperm. It is having the double endosperm in case of coconut. One part of that is edible, second is the potable, means it can be drink, right? Liquid as well as solid part is there, but both are the drupe, right? Now why both are under the drupe? Because their endocarp is hard and stony. Because their endocarp is hard and stony, right? When endocarp is hard and stony, such type of condition of the fruit, you call it as a drupe, right? So why this mango and coconut, although these are belonging to different categories, still they are having the common type of fruit, that is a drupe, because their endocarp is hard and stony. But edible part of the mango will be the mesocarp, whereas the edible part of coconut will be the endosperm. Don't confuse the word endosperm with the endocarp. This is very important thing. Don't get confused in that, right? Okay, next let's talk about the next thing regarding the part of the fruit. What it is carrying? It is carrying the seed, right? In the seed, I already discussed what are their parts. It consists of seed coat and the embryo. Seed coat is consisting of testa and the tegmen. Testa, can I say this is the outer layer? Tegma already I discussed, it is the inner layer, right? And this embryonal axis is the part of embryo. But to nourish the growing seedling into a plant, it is having the cotyledons, right? How many cotyledons can be there? It can be single if it is a monocotyledon, and can be two if it is a dicotyledon, right? Now coming to the other term, even this embryonal axis, we call it as tiglum, right? Tignum is another term given to this embryonal axis, right? Now let's talk about the structure of the seed here. If I discuss regarding the structure of the seed right now, this is the structure of dicotyledonous seed. Obviously, just now I discussed how many cotyledons are there in a dicot seed. 2 cotyledons are there, right? And central one, this you call it as embryonal axis. What do you call it as? Embryonal axis, right? This you call it as an embryonal axis, right? This embryonal axis ends into the plumule part, right? And on the lower side, it ends into the radical part, right? So this is very important point, that if I take this point of connection of this cotyledons, right? Upper side, the upper side of this point of connection, let me show you like this. The upper side of this connection, this one, this part, this you call it as epicotyle part, epicotyle part. And lower part, what we call it as hypocotyle, right? Epicotyle and hypocotyle. Epicotyle ends into the plumule part, and this epicotyle ends into plumule part, hypocotyle is ending into the radical part. Are you getting that? This is next important thing you must remember here, that in which point these embryonal axes are ending. Suppose this is an embryonal axis, this upper side is ending into plumule, lower side is ending into the radical. Upper half is epicotyle, lower half is a hypocotyle part. But being this is a dicot, so how many cotyledons it is having? 2 cotyledons. And what is stored in all this stuff? The food is stuff, so that it should be given to the growing embryo into the sapling or the seedling, right? Now from the outer side, when you will see, you will find hilum here. What is present over there? Hilum. Hilum is a scar which is present on the ovule when it is attached to the this ovary wall. Now I can say hilum is that scar which is attached to the fruit, right? It is the scar. And micropyle is the minute pore. Minute pore, right, where the water is entering into the seed to get into the seedling or the sapling, right? Now this hilum, can I say this is representing the upper side as the base, and the lower side, the micropyle, is representing the apex part. Now what is happening? We have to say the micropyle is present at the tip. Why it is at the tip? Because it is showing the apex part. Whereas hilum, I can say it is present at the base. Why I can say it is present at the base? Because its position is at the base side, below side. It is present below to the micropyle. What thing is present below to the micropyle? That is the hilum, right? Although this hilum is shown in your NCERT book like this, right? It seems to be upper side, but being this is the base and this is the apex, you call it as this is below to the micropyle part, right? So do remember this labeling given in your book: hilum as a scar, micropyle as a minute pore for picking up the water during the germination of the seed, and covered by 2 layers. Again, on the outer side is the testa and inner side will be the tegma, right? So these are the 2 layers around it. Now we have to discuss about the monocotyledonous seed. In the case of monocotyledonous seed, you will find only one cotyledon is there, and that cotyledon we call it as scutellum. What is the scutellum here? You call it as functional cotyledon, right? So functional cotyledon, which is present as a shield around the embryonal axis. Now can I say this embryonal axis in a groove? Groove means a small space. When you see the maize seed, which is a monocot seed, you will find embryonal axis is in that groove, right? And it's this part you call it as embryonal axis. Embryonal axis, upper side I already mentioned you what is there? Plumule part. And plumule part is covered by what thing? Coleoptile. And now this coleoptile, do remember, this is the main important feature of monocotyledonous seed. It is not present in case of the dicot seed. So here coleoptile, can I say this is the leafy sheath which is covering the plumule part. Even the radicle is protected here with the help of coleorrhiza. So what is this coleorrhiza? This you call it as undifferentiated sheath, right? Undifferentiated sheath, that you call it as coleorrhiza. See, the rhiza word is for the roots. As this radicle has to give rise to root system, so it is protected by a layer which you call it as coleorrhiza, means towards the radical side, which has to give rise to the root system, right? So this part is about that embryonal axis and cotyledon. But this is very important to say here, in monocotyledonous seed, there is even the presence of endosperm, right? You will find 2 types of seed, endospermic seeds and the non-endospermic seeds. What are endospermic seeds? where still this endosperm persists after the utilization by this growing embryo. If still it persists, such type of seed you call it as endospermic seed. But if it is utilized by the growing embryo, that you call it as non-endospermic seeds. Endosperm present mostly, this is the feature of whom? Monocotyledonous. Mostly it is present in case of monocots. Are you getting that? Whereas in the dicots, they are non-endospermic mostly. But because we are having exceptions like in monocots, the exception will be of orchids. Orchids are such category which are non-endospermic. These are such monocots which are non-endospermic, right? So usually these monocots are what? Endospermic, but one exception just now I said to you, that will be of orchids, right? But some dicots are even there which should be non-endospermic, but still they have endosperm, like in case of castor. That you must remember. This is very important point. Do hold on that and do revise that. It's important, right? Now coming to this part, endosperm ploidy. The ploidy will be triploid and it is covered by a proteinaceous layer which you call it as aleuron layer. Its chemical composition is of protein and ploidy of that will be triploid. Rest all the structures what we have discussed right now, that all are diploid in its ploidy, right? Either it is a coleorrhizia, coleopetile, plumule, radical, whatever we have discussed, that is all diploid, except which two parts? One is the endosperm which is triploid and aleuron layer which is next triploid. Rest all are diploid structures here, right? So this is about the, in short, we have discussed the structure of the monocotyledonous seeds. More we have to discuss, like perispermic seeds are there. Furthermore, different varieties of seed, how they germinates, what are the exceptions, tiny, and much more production of seeds where happen, least production where happen, much more we have to take, right? But when you will be coming here, then we are picking up that points as well. Please do revise all the points what we have discussed today. Do go with the fruit in detail, but simple fruit is given in the NCERT, aggregate and composite is not in your syllabus. At least you must have that much of knowledge, right? And seeds, you must know the comparison between dicots and monocots, right? Where the scutellum is there, where the coleopetile, coleorrhiza, that will be in monocots. In dicots, such structures are absent, right? This is all for today. Please do keep on revising, give your hard work. Thanks a lot, students. God bless you. Thank you.
Good morning to all. Welcome back. Today's topic is adrenal gland. Adrenal gland is most important gland which is present on anterior region. Which is present on anterior region of kidney. So these adrenal glands are also paired glands present on anterior region of kidney, and these are also known as suprarenal glands. This is known as suprarenal gland, as well as it is also known as forest gland. So this is the suprarenal or forest gland. This adrenal gland has two regions. Outer one is cortex, whereas inner region or middle region is known as medulla. Medulla here. Overall adrenal gland, it is covered by a tough capsule. It is covered by a capsule. Below the capsule, it has cortex. It has cortex, and this cortex has three regions from outer side to inner side. Outer side is zona glomerulosa, and next middle region is known as zona fasciculata, and innermost layer is known as zona reticularis. Below the zona reticularis, next medulla will be there. Medulla is the innermost one. Adrenal gland is a pair of glands. It has two regions. It has two regions. One is outer region is known as adrenal cortex. Outer one is known as adrenal cortex, and innermost region or middle region is known as medulla. So both regions are responsible for secretion of hormones. Both are involving in secretion of hormones. But this adrenal cortex again has three regions. What are those three regions? Already discussed previous slide here. First one is here, outer zona glomerulosa. Zona glomerulosa. Second one is middle region. Middle region is zona fasciculata, and innermost one is zona reticularis. Zona reticularis here. So what is the role of this zona glomerulosa as well as fasciculata and reticularis? All three layers are responsible for secretion of different hormones. Okay, secretion of different hormones. For example, first one, zona glomerulosa. Zona glomerulosa region secretes mineralocorticoids. It secretes mineralocorticoids, whereas zona fasciculata secretes glucocorticoids. Glucocorticoids, and zona reticularis secretes androsteroids. So all these three hormones which are secreted from cortical regions. So what is the role of cortical regions? Means cortical region secretes, this cortical region secretes steroid hormones. The role of this one is it secretes steroid hormones. Those steroid hormones we are calling as corticoids. This is important question. Corticoids are the hormones which are secreted from which region of the adrenal gland? Means answer is cortex. Next, medulla. Medulla doesn't have any regions like this, zona, fasciculata, reticularis. This medulla secretes. This medulla secretes hormones called catecholamines. They secrete catecholamines. These are amino acid derivatives. What are those catecholamines means here? It is epinephrine, or it is also known as adrenaline. It is also known as adrenaline, and second one is known as norepinephrine. Norepinephrine or noradrenaline. Noradrenaline here, and these hormones are also known as 3F hormones. This is known as 3F hormones. So this is the overall classification of adrenal gland. So what is adrenal gland here? The adrenal gland which has outer region called cortex and inner region called medulla. So the cortex region again has three regions. Number one, glomerulosa, fasciculata and reticularis. Glomerulosa secretes mineralocorticoids, fasciculata secretes glucocorticoids, and zona reticularis secretes androsteroids. Anyway, all these three are commonly called corticoids, which are steroid hormones. Whereas adrenal medulla, it secretes a amino acid derivatives called catecholamines, and these catecholamines are produced in response to stress as well as emergency situations, and they are adrenaline or epinephrine and norepinephrine and noradrenaline. Now the first one, adrenal cortex hormones, will discuss. This topic is very, very important. Adrenal cortex hormones. The adrenal cortex hormones are called corticoids, or corticosteroids also, because they are steroid hormones. Corticoids or corticosteroids. There are three types of corticosteroids are there. What are those means? Whichever corticoids involves in glucose metabolism. Whichever corticoids they are involving in glucose metabolism are called glucocorticoids. This is important point. What is the definition of glucocorticoid? These glucocorticoids are secreted from zona fasciculata layer of adrenal cortex. It is known as glucocorticoids. What are glucocorticoids definition means? Whichever corticoids plays an important role in glucose metabolism or sugar metabolism, they are known as glucocorticoids. The main glucocorticoid is cortisol. It is actually cortisol. Cortisol is the main glucocorticoid. And next, second type of corticoid, whichever corticoid involves in water and electrolyte balance. Whichever corticoids involves in water and electrolyte balance, they are called mineralocorticoids. They are called mineralocorticoids. These mineralocorticoids, they are secreted from zona glomerulosa. Mineralocorticoid. Example for mineralocorticoid. The main mineralocorticoid given in the textbook is aldosterone. It is actually aldosterone here. So which of the following are cortical hormones? Means we can say cortisol as well as aldosterones. Both are corticoids only, but the first one is the glucocorticoid and the second one is mineralocorticoid. Next, third type of corticoid is there. Whichever corticosteroid involves in formation of some axial hair, pubic hair, etc., or facial hair at puberty time. At puberty time, they are called androcorticoids. They are called androcorticoids here. So these are the three different types of corticoids produced from cortex region of adrenal gland. Cortex region of adrenal gland here. Okay, first we will discuss about cortisol. What are the points comes under cortisol here? Because this cortisol is very important topic. First one. Cortisol is what type of steroid or what type of corticoid here? It is a glucocorticoid. It is a glucocorticoid, and next it is secreted from. It is secreted from zona. Is it glomerulosa or fasciculata? This is fasciculata. Zona fasciculata of adrenal cortex or adrenal medulla. This is cortical hormone of adrenal cortex. Adrenal cortex here. And the role of this cortisol is, it involves in a process called gluconeogenesis. Gluconeogenesis. The meaning of gluconeogenesis is formation of sugar. Neo means new. Formation of sugar. Formation of sugar from non-carbohydrate sources. From non-carbohydrate sources is known as gluconeogenesis. What is the role of cortisol? Cortisol involves in gluconeogenesis, and this cortisol production, it is influenced by ACTH. In yesterday's topic we have discussed here, ACTH means adrenocorticotropic hormone. That hormone is secreted from the pituitary gland, and that hormone induces the cortex to secrete cortisol. And these are the functions of cortisol. First one is it involves in gluconeogenesis, and next one is here it involves in lipolysis. Lipolysis means here breakdown of lipids. And the third one is here it involves in proteolysis. Proteolysis means breakdown of proteins into amino acids here. Okay, the role of cortisol is it involves in gluconeogenesis, lipolysis as well as proteolysis here. And next one, it inhibits. The role of this cortisol is here it inhibits cellular uptake and utilization of amino acids. Why do this hormone is inhibiting the cellular uptake and utilization of amino acids? Means because these amino acids, they have to change their path towards the gluconeogenesis, because gluconeogenesis means formation of sugar from non-carbohydrate sources, means it may be amino acids here. So generally the amino acids are the monomers for protein synthesis. Instead of that pathway, now these amino acids are moving towards the gluconeogenesis. For that reason, this hormone inhibits the cellular uptake and utilization of amino acids. Due to all these gluconeogenesis, lipolysis and proteolysis, it causes increased glucose levels. It causes increased glucose levels in blood. In the blood. What do you call the condition? Increased glucose levels in the blood is known as any idea? It increases the glucose levels in the blood, means this condition is known as hyperglycemia. Suppose question is cortisol induces hyperglycemia. Yes, correct, because it increases the glucose levels in the blood, so it induces hyperglycemia, and we can call this cortisol as hyperglycemic hormone. Just like glycogen, we are calling this hormone as hyperglycemic hormone. Hyperglycemic hormone here. So these are main functions. First one is it involves in gluconeogenesis, lipolysis as well as proteolysis. And second one is it inhibits cellular uptake and utilization of amino acids. Apart from this role here, the next role is this gluconeogenesis, this cortisol maintains cardiovascular system. It maintains cardiovascular system as well as kidney function. Their role is to maintain cardiovascular system as well as kidney function. Here. And next one. Cortisol has anti-inflammatory action. It has anti-inflammatory effect. Anti-inflammatory effect means here it can suppresses the inflammation here. Allergic time. During allergic time, the cortisol is used as a drug and it acts as an anti-inflammatory drug here. Next, even it has immunosuppression effect, means the role of this hormone is it suppresses immune system. Even it has a role to suppress the immune system. For that reason, the cortisol is used for the patient who has undergone organ transplantation. So why do we are providing this cortisol for organ transplantation patients means here to prevent the rejection. That means to prevent the graft rejection here. Next, even it has stimulatory effect. Even it has a stimulatory effect on RBC production. What do you call the RBC production? RBC production is a process. It means formation of RBC from the stem cells of bone marrow, and it is known as erythropoiesis. It is known as erythropoiesis. Cortisol plays an important role in erythropoiesis. Erythropoiesis here. So once again, what are the roles of cortisol here? First one is it involves in gluconeogenesis, lipolysis and proteolysis, and it inhibits the cellular uptake and utilization of amino acids. Then it maintains cardiovascular system and kidney function, and it has anti-inflammatory effect which can be used to treat allergic reactions. And next, it has a effect to suppress the immune system. For this reason, the cortisol is used as a drug to prevent graft rejection. And then it has stimulatory effect, or it stimulates the RBC production called erythropoiesis. So these are the main functions of cortisol. Next one is here aldosterone. next one is aldosterone hormone. What is aldosterone hormone? Aldosterone hormone is a mineralocorticoid. It is a mineralocorticoid, and this mineralocorticoid, it is secreted from zona glomerulosa. It is from zona glomerulosa. This is from fasciculata and this is from zona glomerulosa. Next, what is the role of aldosterone means here? This aldosterone acts on renal tubules. Acts on renal tubules, that is DCT, and involves in renal tubules, and it involves in number 1, reabsorption of, so this aldosterone is known as salt retention hormone. It is a salt retenting hormone, and the role of this aldosterone is it reabsorbs reabsorption of sodium ion along with water. Sodium along with water. The role of this hormone is it acts on renal tubules, that is DCT, and this is known as conditional reabsorption. The process is known as conditional reabsorption. In this conditional reabsorption, where there is a reabsorption of sodium along with water from the filtrate, and then simultaneously it secretes potassium and phosphate ions. Potassium and phosphate ions into the filtrate. Into the filtrate means for excretion out. Into the filtrate. So this is the role of aldosterone here. So where do this aldosterone acts means here, this aldosterone acts on renal tubules, and their main role is to reabsorb the sodium along with the water here. And meanwhile it secretes potassium as well as phosphate ions into the filtrate. This is aldosterone. And next one here, and next hormone, glucocorticoid over, mineralocorticoid over, and then androsteroids. Or androcorticosteroids here. So the role of these hormone is here, it involves in axial hair, facial hair, and body hair formation at pubertic time. So that is the role of these hormones, and these hormones are secreted from, cortex region only, but it is secreted from zona reticularis. Here. So these are the functions of adrenal cortex hormones. Now next one is adrenal medulla. Cortex over, next adrenal medulla. Where is adrenal medulla present? It is inner one here. So this adrenal medulla secretes epinephrine or adrenaline and noradrenaline as well as norepinephrine. These two are collectively called catecholamines. These two are known as catecholamines and they are amino acid derivatives, and these hormones are also known as 3F hormones. 3F hormones. It means when do these hormones are produced? These hormones are produced, these two hormones, they are produced in response to stress as well as emergent situations. Stress and emergency conditions. Because of this hormone, the person will try to escape. From that extreme situations. So it is known as 3F. Why it is known as 3F hormone means because it plays an important role to fight against the situation or to get fear or flight. Simply they will escape out from the situation here. So this is a 3F hormone, epinephrine as well as norepinephrine. Both are collectively called catecholamines. And what is the role of this epinephrine is? The role of epinephrine and norepinephrine. First one, this hormone involves in breakdown of glycogen. What is glycogen? The glycogen is a polysaccharide. It is a storage polysaccharide present in liver. It involves in breakdown of glycogen here. Glycogen into individual or monomeric units called glucose. And what do you call this process? This process is known as glycogenolysis. This is known as glycogenolysis here. Role of cortisol is gluconeogenesis, and the role of epinephrine and norepinephrine is it induces the breakdown of glycogen into glucose, and this process is known as glycogenolysis. Along with this, even it will involve in lipolysis, that is breakdown of lipid, and then proteolysis also. Because of all these, the blood glucose levels increases. Because during panic situations or emergency situations, we need some energy to escape from the situations. For that reason, drastically the blood glucose levels increases. And even this condition is also known as hyperglycemia. It is known as hyperglycemia, and even you can call this epinephrine and norepinephrine are hyperglycemic hormones because it induces the hyperglycemia. And this adrenal medulla will be stimulated by means of nicotine in the case of smokers. It will be stimulated by means of nicotine in the case of smokers. In the case of smokers, this nicotine is a chemical present in the tobacco. They induces the medulla and they starts to produce epinephrine and norepinephrine even in the absence of emergency situations or stress conditions here. Next, along with this one, the role of epinephrine and norepinephrine is it increases sweating. During panic situations, generally will feel sweating here. It increases sweating, and then it increases heartbeat, and it increases strength of heart contraction. Even the cardiac output also increases here. Strength of heart contraction. And then it increases rate of respiration. During panic situation, our breathing rate will increases. Rate of respiration also increases. And then piloerection. Piloerection means here goosebumps. Goosebumps will take place, and then pupil dilation also takes place. Pupil dilation. What is pupil dilation? Means enlarging of pupil. Why do the pupil gets enlarged? Means here they are in emergency situation, so they want to escape. Means here they should have a clear vision. For that reason, the pupil dilation also takes place. So these are some other physiological conditions here: increasing the sweating, next heartbeat, strength of heart contraction, rate of respiration, even the piloerection as well as pupil dilation will take place. So these are the functions of medulla. It means this epinephrine as well as norepinephrine. Main one is these points are important. These are important points here. So adrenal cortex as well as adrenal medulla is done, and next one will move to disorders. We'll move to disorders here. Disorders. Number 1, Cushing's disorder. Cushing's disorder. What is Cushing's disorder means here are this disorder which is caused due to oversecretion, which is caused due to oversecretion or hypersecretion of cortisol, or otherwise we can call it as adrenal cortex hormones. Here. So Cushing's syndrome or Cushing's disorder is belonging to adrenal disorder, which is caused due to hypersecretion or oversecretion of adrenal cortex hormones. So this is the picture of Cushing syndrome here. Here the person is suffering. How to identify that the person is having this Cushing syndrome means these are the one. Their face will be moon shaped. The face will become round here, and it is moon in shape, and then they will have a red cheeks. Next, back side here they will have a hump like structure. This is known as a buffalo hump, and then even they will get some stretch marks, and their arms will become thin. And then they will get some rashes also here. So these are the symptoms of Cushing syndrome. Even here also. So this is a boy in normal condition, and he got this syndrome. Automatically his face has become round shape. Have you seen, even the fat is also accumulated under chin, and then he is having red cheeks also. So this is about Cushing's. Next one, Addison's. In textbook, Addison's one given. Addison's disease is exactly opposite to Cushing's one here. This Addison's disease is caused due to undersecretion. It is mainly caused due to undersecretion or hyposecretion, or even it is also known as deficiency also. Undersecretion, deficiency, or hyposecretion of which hormone means same. It is also caused due to adrenal cortical hormones, especially cortisol only. But this is hypo. Whereas the Cushing's was hyper, and this is hypo. It causes Addison's disorder. Next, in this disorder, the person is experiencing weakness, next tiredness, and then wastage of muscle. wastage of muscle. So these are the symptoms of Addison's disease here. Yes, this is the Addison's one, where they are having many problems here. They will have some autoimmune destruction, abdominal pain, and next one is here weight loss. Easily they will get fatigue, and then weakness, and then they are experiencing stress also, low sodium levels, salt cravings, etc. Okay, these are the different symptoms of Addison's one here. Even these people will appear this type of face. And next one, this last one is virilism. So what is virilism means? Virilism is a condition where there is a hypersecretion of androsteroids. Here, this is also a type of adrenal cortex disorder only here. In this case, the person is secreting more amounts of androsteroids. Because of that, they will get some unusual body hair as well as facial hair, especially in the case of females. Okay, these are all about adrenal gland here. So what are the disorders are there? One is Cushing's, and second one is Addison's, and third one is here virilism one here. Once again, a small revision. Adrenal gland is known as suprarenal because it is present at top or anterior portion of kidney, and overall this gland is covered by a capsule. It is covered by a capsule, and below the capsule it has cortex. And below the cortex, it means innermost, it is known as medulla. Cortex is having zona glomerulosa, middle fasciculata, as well as zona reticularis here. So zona glomerulosa secretes which hormone? Means it is mineralocorticoid called aldosterone, and then fasciculata secretes glucocorticoid called cortisol, and reticularis secretes androgens here, and whereas medulla will secrete the three of hormones are catecholamines called epinephrine and norepinephrine here. Is there any disorders for medulla region? Means there is no disorders for adrenal medulla, only the disorders are there for adrenal cortex only. Adrenal cortex here. Even the kidney also same. Kidney outer region we are calling as cortex, and inner region is known as medulla. So same as kidney, even this adrenal gland also has outer cortex and inner medulla here. Same point. So what is the definition of glucocorticoid here? Whichever hormone involves in glucose metabolism is known as glucocorticoid, and the main glucocorticoid is cortisol. And whichever corticoid involves in water and electrolyte balance, that is known as mineralocorticoid. Example is here aldosterone. Whichever corticoid involves in the formation of body hair, facial hair, especially at pubertic time, they are known as androsteroids or androcorticosteroids here. So that's all about this adrenal gland. Thank you very much.
Okay, good morning everyone. I hope you are doing well. Right? Good morning, good morning. Okay, fine. So, yesterday we did the table for VSEPR theory. Using that table, you can tell the shape or electronic arrangement of a molecule. I told you the shape depends on the number of sigma bonds and lone pair, right? But yes, when you are saying the shape of something, you will not look at lone pairs. Okay, it will decide the shape, but when you are looking for the shape, you will cover the lone pairs and you will look at the bond pairs only. Right? Clear? So that's it. So structure, I will say again, structure, geometry, you can say depends on number of sigma bonds and lone pairs. It will not depend on pi bonds. Okay, for that we can see some examples as well, right? So try to answer these questions, right? Let us see. I'm giving yes, good morning. So I'm giving you some examples. You have to give me the shape of that molecule, right? So please find shape of following. Clear? So first one I'm saying here, you can have XC F4. You're having here XCF4, or I'm saying here XCO4, right? And next I'm taking here, imagine we're having here SO4 2 negative, or I'm saying here H2S. Okay, so you have to calculate how many sigma and pi bond and lone pair our center atom is having, and using that you can answer the shape as well, right? So first of all, if we go for the XCF4, fine. First of all, tell me the xenon here is having how many valence electrons? It is having 8 valence electrons, right? Xenon is having 8 valence electrons. Okay, so I will write xenon in center, right? And I am writing here 4 fluorine as surrounding atoms. Clear? So out of 8 valence electrons of xenon, you know the fluorine will make what? Single bond, single bond, single bond, single bond. Out of 8, 4 valence electrons are used, 4 still remaining. Those 4 valence electrons will become 2 lone pairs, right? So by the table of VSEPR theory, we can say whenever center atom is having 4 sigma bonds and 2 lone pair, the shape is what? Square planar, right? I will say the shape is square planar here. Remember? Clear? Fine. Now if I come to XCO4, right? If we were to go for XCO4, xenon here again is having how many? 8 valence electrons, right? XC, xenon is having 8 valence electrons, and I am showing here 4 oxygens as surrounding atom, right? And you know that oxygen will make what here? Double bond. A neutral oxygen will make here double bond. Clear? So you can see here the xenon used all its 8 valence electrons in making bonds. There is nothing left. There is no electrons, no valence electron left. Okay? So that's why xenon will not have any lone pair. So I can say the xenon is having 4 sigma bonds and 0 lone pair. 4 sigma bonds, 0 lone pair. It means what? The shape is tetrahedral. Okay? You can use the table. You see carefully, the pi bonds will not make any difference in the shape, or you can say in the geometry. Clear? It is tetrahedral. Even if I have only 4 sigma bonds, nothing else. So like CCl4, CH4, it is tetrahedral. Here I have 4 sigma bond and 4 pi bond even, but still it is what? Tetrahedral. It's very important point. Pi bond will not decide the shape and geometry. Clear? Right? The next thing I will take sulfate ion here. The sulfate ion we can take. Now we are having SO4 2 negative. Fine. SO4 2 negative. So 2 of the oxygens will carry which charge? -1 charge, right? So oxygen with negative charge will make what? Single bond, right? it is making single bond, single bond. And you know sulfur have 6 valence electrons. So out of 6 valence electrons, 2 are used here. It will make double bond here, it will make double bond here, right? So in this way you can see sulfur used all its 6 valence electrons in making 6 bonds. So no lone pair left. Clear? So sulfur is having here 4 sigma bonds without any lone pair. That's why same again, it is what? Tetrahedral. It is again a tetrahedral. Fine, good. The next thing is H2S. H2S, right? Sulfur. Again, sulfur have 6 valence electrons. Now, I am putting 2 hydrogens, okay, fine, as surrounding atoms. Hydrogen, you know, as a surrounding atom makes single bond. So, it will make here single bond, right? Out of 6 valence electrons, 2 used in making bonds, 4 remaining. Those 4 will be as a lone pair, okay? And you know, when our center atom have 2 sigma bonds and 2 lone pairs, what do you call it? Bent. It is bent shape. You can say like water. You can say bent, or you can use word angular or V shape. It's fine. Okay. Clear? Or you can use which word? Mainly angular word we use in this term. Okay. That's fine. Now, if I want to ask you, like we can revise our previous topic as well. So tell me the hybridization of our center atom, xenon. Okay. So we can see the xenon is having 4 sigma bonds plus 2 lone pair. Total how much things? 6. 6 means what? sp3d2. Fine. Xenon here is making 4 sigma bonds and 0 lone pair. So total number 4. 4 means what? sp3. Okay. Next you can see sulfur here. Again you are having 4 sigma bond, 0 lone pair. Total sum is 4. So 4 means what? sp3. Fine again. And the next here again, if you see total here 2 sigma bonds, 2 lone pair. It is coming 4. 4 means what? sp3. Clear? These are having different shapes. But you see here, this one is having same hybridization. So yes, it is possible. You can say center atom is having same hybridization, but the shape is different. Clear? All are sp3, 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 but shape is different. Okay, clear? Done? Now, one more example I am giving. Look at this one. Try this one. Try XCF6. Right? Your work is to just tell me it is having how many sigma bonds. In this molecule, xenon will have how many sigma bonds and how many lone pairs. It is our main task. How many sigma bonds and how many lone pairs. Shape I will tell you, don't worry about it. Fine. So in this case, if you see, here you see xenon is having how many valence electrons? 8 valence electrons again, right? So xenon with 8 valence electrons is available here, is sitting in the center. Now I am showing you the 6 fluorine atoms as surrounding atoms, and you know that fluorine to make single bond always. So 1, 2, here like I am making single bond with every fluorine. So in this way it made 6 bonds. So xenon used its 6 valence electrons and 2 electrons are still remaining. Those 2 electrons will make a lone pair like this. Okay. In a special case, the shape, if I say, the shape is distorted octahedral. The shape of this molecule is distorted octahedral. I hope you are clear. It is very special example. Okay. You are having 6 bond pairs, 1 lone pair. It is like you can say it is one of its own kind of example. Okay, you will not see any other examples like this. 6 bonds, 1 lone pair. It is distorted octahedral. I hope you are clear, right? You see, if I will not take the lone pair, only 6 bonds, it will be a perfect octahedral. But because of this lone pair, some disturbance or distortion will come in octahedral. So we are calling it what? Distorted octahedral. Fine, clear? So one last question on this. So please find shape of following. Right? First one I am giving like here. Try CCl4. Second, you can take OF2. Okay. Third, you can take PCl3. Okay. Right? And you can take ClO3 minus. Okay. So we have to find the shape of following molecules or ions. Fine. Again, our main task is to find our center atom is making how many sigma bonds, pi bonds and lone pairs. And then after finding this, what is more important? Sigma and lone pairs, it will decide the shape. Okay. So first I am taking CCl4. Fine. In this case, the carbon is having how many valence electrons? 4 valence electrons. Fine. So I am drawing here. Carbon is having 4 valence electrons. Carbon is center atom. And these chlorines are surrounding atom. And you know that halogens make single bond when these are present in surrounding. So in this way you can say, if our center atom is having 4 sigma bonds only without any lone pair, so it will make tetrahedral shape, right? It will exist in tetrahedral shape to minimize the repulsion between the bonds, or you can say electron pairs. Next is OF2. O here is having how many valence electrons? 6 valence electrons. O is having 6 valence electrons. Fine, clear? So you will see, out of 6 valence electrons, you will see, it's OF2 na? So I am putting fluorine as surrounding atoms. Clear? You will see, fluorine to make single bond. So single here, single here. Still, out of 6, 2 are used in making bonds. So 4 remaining. So 4 remaining, but become what? 2 lone pairs. Okay? You can see the shape is bent, or you can say angular. Clear? 2 bond pair on center atom. 2 sigma bonds I am saying. And 2 what? Lone pairs. So it is angular. Fine. The next thing is PCl3. So P here, the phosphorus here is having how many valence electrons? Sorry, 5. Phosphorus is having here 5 valence electrons. Fine. So I'll keep phosphorus here, and then I'm taking Cl3. So you can have here Cl, Cl and Cl. We are having here what? Chlorines. Fine. You will see phosphorus will make single bond with chlorines. Out of 5 valence electrons, only 3 are used in making bonds, right? How many remaining? 2 are remaining, right? Out of 2 remaining, you will see it will make a lone pair. So in this case, it is having what? It is having 1 lone pair and 3 bond pair, right? So you can say this is our pyramid. This is our pyramid. Fine. I hope we are clear, right? And the next one is your ClO3 minus. So what is there in ClO3 minus? Chlorine is there. Chlorine is having how many? Chlorine having how many? 7 valence electron. Fine. You see chlorine here. I am showing your oxygens. Oxygen here, oxygen here, oxygen here. And one of the oxygen is negative charge. One of the oxygen is here negative charge. Right? Clear? Now you will see the O negative charge oxygen will make what here? Single bond. Clear? Whereas this oxygen will make a double bond, and here also what? Double bond. Fine. Out of 7 valence electrons, 1, 2, 3, 4, 5 are used. So what is remaining? 2 remaining. 2 remaining become 1 lone pair. Right? That's why you will see this is what? Pyramidal in shape. Trigonal pyramidal. Whenever center atom is having 3 sigma bonds and 1 lone pair, it is trigonal pyramid. Okay, I hope this will help you to find shape or geometry of the molecules. Fine, clear? Now we will see a small topic. Next small topic, I will say, you can say the formal charge, right? Okay, fine. Okay, bache. So next one is your formal charge. Next is your formal charge. Fine. Sometimes they give us molecules or living structures and they will ask find the formal charge on this particular atom. So we can find the formal charge, right? So we have to understand the difference or actually what is the meaning of a formal charge, okay? So I'm writing definition. Formal charge is the difference in valence electrons of an atom. Is the difference in valence electrons of an atom in isolated state and the number of electrons and the number of electrons assigned to the atom in given molecule or given living structure, you can say, to the atom in given structure. Okay, so it is a difference, like I will say oxygen is having 6 valence electrons in its isolated state when you take just oxygen, and it is having 6 valence electrons. And when that same oxygen is present in some molecule, so in that molecule it is getting how many electrons. So the difference between the valence electrons and the electrons assigned to that atom in given living structure or given molecule or given structure is known as formal charge. Okay, very easy question they asked from here. Okay, so we'll see. First of all, we have to learn the formula to find the formal charge. Clear? So what is the formula of formal charge? First of all, you'll say valence electrons. That atom is having how many valence electrons, right? Minus number of unshared electrons. In that molecule, it is having how many unshared electrons, right? And minus 1 by 2. You will say here 1 by 2. If I say here, this is valence electrons. This is number of unshared electrons minus half of number of shared electrons. Because you know, in shared electrons, 1 electron is coming from, or in shared electrons I will say the bond is there. So we count 1 here and 1 here. Okay, so that's why we are taking half. You have to half the number of shared electrons, right? And the very common, the NCERT example, which always they ask in most of the questions, like in O3, I am having O3, ozone. In ozone, if I make the structure, you will see this is ozone, right? So in ozone, I want to find the formal charge on all the oxygens. Fine. So what is that? You will see here. First of all, I'm showing here the electrons, right? Even after showing bonds, I'm showing the electrons also, so that you can see how many unshared electrons are present. Okay, I'm calling this oxygen as 1 oxygen, this is oxygen 2, this is third, to avoid confusion. Okay, in this I'm calling this oxygen as first, second, third. Okay, I'm just giving it name. So I am finding the formal charge on first oxygen. We are finding the formal charge on first oxygen. Fine, right? So you will see this oxygen or oxygen in isolated state have how many valence electrons, beta? 6, right? So it is having 6 valence electrons minus it is having how many unshared electrons? You can see 1, 2, 3, 4, 5, 6. It is having 6 unshared electrons, right? Minus 1 by 2. Now shared electrons. So you can see it is making one bond. In one bond means it is having 2 shared electrons, right? One bond means 2 shared electrons. Fine. So you can see 6 minus 6 minus half 2. What is coming from here? Minus 1. So the formal charge on this first oxygen is what? Minus 1. The formal charge on the first oxygen is what? Minus 1, right? Now we can go for the formal charge on second oxygen as well. Clear? Right? So what is this? You will see. What I can say here? Second oxygen, 6 valence electrons, right? Minus unshared. How many are unshared? There are 2 unshared, right? There are 2 unshared. We are having here 2 unshared, right? And 1 by 2 here. And now see, it is having how many shared? 1, 2, 3. 3 bonds. 3 bonds means 6 unshared, right? So you will see, we'll keep here 6. I'm saying once again, 6 valence electrons, 2 unshared electrons, and 3 bond means 6 shared electron, right? So if you keep it here, so you can see from here 3 coming, 2 coming, so how much remaining? 1. The formal charge is coming 1 for this. Fine, clear? The next thing is the formal charge, right, on third atom. Formal charge on third atom here. Fine. This oxygen here you can see. Again it is having 6 valence electrons, right? How many unshared? You can see 1, 2, 3, 4. 4 unshared electrons, right? And minus of 1 by 2. Clear? Minus of 1 by 2, how many shared? 1, 2, 3, 4. 2 bonds means 4 shared electron, right? So what is coming from here? 0. Okay, so on this oxygen the formal charge is minus 1, here 1, and here what? 0. This is the way you can find the formal charge in the given structure. Fine, clear? So I am giving you 1 or 2 questions on the formal charge. Please try. Okay. So I am giving find formal charge of sulfur in given structure. Okay. So here we have, this is our sulfate ion, right? Look at this. This is our sulfate ion. Fine. If I show you, okay, fine, that's it. So I want to find, I'm saying find the formal charge on sulfur in this structure. In this structure, find the formal charge on sulfur, right? Can you find? Right. So if I want to find the formal charge of sulfur, you see carefully. Okay. So what is it? First of all, how many valence electron of sulfur? 6 valence electron, right? In isolated state. Minus, are there any unshared electrons on sulfur in this case? Are there any unshared electron? You can see sulfur after making 6 bonds definitely is not having any lone pair left. So there is no lone pair or no unshared electron. So you will say 0. And minus of 1 by 2 I am taking here. Now you see 1, 2, 3, 4, 5, 6 bonds, right? 6 bonds means 12. 6 bonds means 12 unshared. So 12 shared electron, right? And we are dividing 1 by 2. So 6 minus 6 coming how much? 0 is coming. How much coming? 0. Fine. The next thing, if you see it is formal charge. Okay, that's it. Fine. The formulas are coming how much? 0. Okay, right? I am giving you one more structure, the Lewis structure of sulfate ion. Okay, this is the actual more stable structure. Like I am writing here one more structure. Okay. So in this case, sometimes we show it by the dative bond also. By the dative bond you will see, okay, this way. Okay, in this we are drawing the structure with the concept of d pi p pi bond. Okay, right? Here I am drawing this by coordinate bond, dative bond, right? So if you find the formal charge in this structure, what is the formal charge of sulfur in this structure? Can you find? If you try to find the formal charge, you will see It is how much? 6 valence electrons. Sulfur is having 6 valence electrons. Now you see 0 unshared electrons, okay? Because there is no lone pair on sulfur. Now 1 by 2. It's 1 by 2. And we are having what here? How many bonds are here? 4 bonds. 4 bonds means how many shared electrons? 8 shared electrons, right? Clear? So what is coming from here? 4. So 6 minus 4, how much coming? 2. So in this structure, the formal charge of sulfur is coming how much? 2. But in the upper structure of sulfate ion, formal charge is coming how much? 0. So actually if both structures are coming, both are present, and if they ask which structure is more stable or more like you can say more acceptable, so we will go for this one. Structure with lesser formal charge is considered to be more stable. Okay, this structure I am drawing using the you can say dative bond concept, or you can say the Lewis structure. But here I am drawing this by using the d pi p pi concepts, right? Clear? So this structure is more acceptable and more stable because here the sulfur is carrying less formal charge. Lesser the formal charge on your atom, more the what? Stability. Clear? I hope you are clear, right? Now I am giving you one more structure and you will find the formal charge on that atom. Okay, so find formal charge on chlorine. I am giving. Find the formal charge on chlorine in the given structure. Fine. So here we are having chlorine. If I draw this ClO4 negative, okay, it is ClO4 negative like this one. And I am saying find the formal charge on the chlorine in this structure, right? What do you say? Okay, apply the formula. So you will see how many valence electrons are here on chlorine? 7. Minus, there is no unshared because all the electrons of chlorine are used, right? And minus of 1 by 2. How many shared electrons, right? So here you can see 1, 2, 3, 4, 5, 6, 7. 7 bonds. 7 bonds means 14 shared electrons, right? You will keep 14 here. 7 here, minus 1 by 2, 14. What is coming from here? 0. The formal charge in this structure. But lesser the formal charge. First of all, this is not possible. You are saying that the formal charge will come minus 2 plus 2. That is not possible, right? But I will say lesser value. You will always get whenever you compare. Like here I am comparing the formal charge coming 0. But if you take chlorine here and you show the coordinate bonds, okay? Like if I say if I am taking here instead of this bond, I will take coordinate bond, right? Like I am writing Cl here. This is O negative, and I will take here coordinate bond. Okay. Now if you find the formal charge, whenever you have two structures, like one is your with the d pi p pi concept and one with your you can say the Lewis structure or with the coordinate bond. So you will see in one case it will be 0, in one case it will be plus, like you can say 2, 3 like this way. So wherever it is 0 or lesser, okay, you will see it is more stable. Is it better? Clear? Fine. So if you find here in this structure, what is the formal charge coming? So I will say 7 valence electrons, 0 unshared and 1 by 2. How many bonds here? Tell me. Is it better? What will be its formal charge of chlorine on this? Is it better? Pramukh Charita. Okay. Tell me better, what is the name? What is the formal charge here? Yes, that's it. So how many here? 4 bonds. 4 bonds mean how many? 8 electrons. So what is coming? 3. That's why I will say this is a more stable or more acceptable structure. Okay? With lesser formal charge. So you will always get 0, 2, 0, 3, 0, 1. So the 0, the lower formal charge structure will be considered as more stable. I hope we are clear. Okay, everyone. Okay, so today we finished our VSEPR theory topic. I said we just did how to find shape. More details we will do in our regular classes, and a small topic as well. We did our formal charge. How to find formal charge? I am saying once again, valence electrons minus unshaded electrons minus 1 by 2 of shaded electrons. If they give two structures of same ion and they want to ask which one is more stable, so structure with lesser formal charge will be more stable. Okay, it will be like this always. One is having 0, one is having 2. So structure with 0 formal charge will be more stable. Like I gave this example, or like this also. Fine. Okay, beta. I hope this will help you. So this is it for today. Okay. Remaining things we'll see next class. Okay. Bye everyone. See you.